Hello students, today's concept is based on concept of a massive rope system, concept of block with a massive rope system. Block with a massive rope system, it's a mass of the rope is considered. Its rope is what? This the mass of rope is considered. It's a the mass is considered. In earlier discussions, we did the mass of the rope means what ideal string we considered. For the ideal string, the mass is so as compared with the mass of the body is what very small. So the tension at every point was same. But here mass of rope is considered means what? When mass is considered, then tension is different. Okay, tension is different at different points. So different at different points. This is what it's a mass. Okay, when a mass is considered now. Now just imagine that I'm taking about on the horizontal surface. On the horizontal surface, a block is placed, and to the block, so a rope is connected with this. This is what? It's a block. Its mass is m, and the rope is connected like this is the rope. The mass of the rope is it's a m. This is mass, and it's a capital letter M. I'm applying a force on this. The force which is acted here, so this at this position is the external force. So when you apply the external force on this, the tension at different points, if we choose at this position what is the tension, or at this position what is the tension, at this position what is the tension in the rope. So we can say the tensions here T1, next one T2, next T3 at any different positions, it depends on what? Mass distribution. Okay, so that's what T1 is not is equals to T2 is not is equals to what? T3. Okay, so when it is given as just a basic condition, so if you see the whichever this at the T1 if I take on it here, whichever the force is acted by this on it, it will be towards here. In the same force for the action and reaction forces will be acting on this. Okay, so F1 bar is equals to minus F2 bar. Magnitude of F1 is equals to magnitude of F2. At every point this is going to happen. Now, so if you just I'm talking about either this situation, whichever is taken here is the horizontal, and this one is the block, and here is what some rope is like, whose mass is considered. Its mass is capital letter M. Its mass is what? It's a small letter m. This is what? Applied force. Just you consider for the problem solving which the mass is considered. Okay, so consider just what is the trick we need to follow for the problem solving. Say for the problem the mass of this is here. You imagine like whichever it's like a block. This is one block. Its mass is considered. Whenever mass is considered, it's a, so this is you treat it as it's a one massive body. Means so you have the two bodies like. Now I'm drawing the free body diagram. Its length is what? This is what? It's a length L. L is the length. Okay. So next one here, this is it's a mass M, and next one here is that. So where you want to find it, I'm taking as like this. So this is what? Applied force. Okay. So it's what? Small letter. Its mass is M1. Its mass is what? M2. Now, so here just whichever the force is acted by this on it, and the same force is acted, it's what is this T. So applied force is in a rightward direction, acceleration is also in the rightward direction, like. So now we can go for the free body diagram. The free body diagram is what? The acceleration of this one is in forward direction. The acceleration of this is also in the forward direction. Yes. So for the first case, if I go for this free body diagram, it's mass, okay, capital letter M. This is what? It's a M2. Acceleration in the forward. So how to write the equation? F net is equals to, net force is equals to, what do you write? Capital M plus a small m2, okay, into what? Just a minute. I'm changing this. So here you can go for this. F net force is equals to, yes. How many forces are there here? It's a, this is what? T. Correct. So if you go for this is what? In this in a single rope, it's a M1 is considered. Okay. So here I can say this. Its mass is like, this is what? M1. It's a applied force capital F. Tension is what? It's a T. Acceleration is in forward direction, individually taken. Yes, this is what individual FBD has taken. I need to write its equation. Okay, equation. F net is equals to, how many forces do you have acting on it? It's a T. F means what? MA. MA means what? Capital M plus M2 times of A is equals to what? It's a T. Okay, it's a T. Then A is equals to what to write? A is equals to T by, A is equals to T by, so capital M plus M2, like we can go on this. For this means what we have written, A is equals to T by M plus what? M2. Next, if you go for this acceleration towards here, net force F net is equals to what you say? It's a F minus T. F net means what? M1A is equals to what? F minus T is your second equation. This is your first equation. So here is the situation like. Then how you get it about M1 and M2? So it's what? Total mass is M at this particular length. What is the, for example, its length is what? This is X. This will become as what? L minus X. What mass is distributed in the length X? Okay, then how do we take it as? It's a linear mass density from linear mass density. So what is the condition for the linear mass density? So lambda is equals to mass per length. Total mass per total length M by total length L. This mass individual, which mass you want to find it, it's what? M1. Length is what? X. M1 is equals to what you say? M by L into what? X. Sir, if you want to find M2 for this M2, M2 is what? Total mass M by L. Mass for this portion M2 by length is what? L minus X. M2 is equals to what you say? M by L into what? L minus X. Here M2, this is what? M1, we can calculate it. Is the method. So first, whenever mass of the string is considered, tension is different at different positions. Here, whichever at the particular length X, so what is the tension at this point? And next one, so just I taken as its free body diagrams. And I have chosen about this, at the X distance, what is the mass is distributed here? What is the mass is here? At the remaining L minus X distance, what is the mass is distributed? So then about, so how do we calculate its mass means what? From the linear mass density. Linear mass density lambda is equals to what? Mass per length. So this based on this one, I chosen about M1 and M2 is the method of problem solving. Now I'm taking an example. Okay, so just for example, one question I'm taking about this. Say one model is that, draw a few this. This is the horizontal surface. Okay, on the horizontal surface, a rope is kept. Is the rope. Okay, let it be its mass. Something, the mass of this one is what? 2 kgs. You can take it. No issue on it. It's at 2 kgs. Okay, so this is what? Here is the rope. Yes, its mass is 2 kg. Its length is what? 1 meter. Just to imagine, it's a 1 meter. Whatever the question has given. But this is what? For some force is applied, 4 Newton force is applied. 4 Newton force is applied. My question is about find what is acceleration of the system. What is the acceleration of the system? When you apply the force on this, so what is the acceleration? For the second one is about, so what is the tension? Tension at, this is 1 meter, no? I'm talking about a 1 meter means what? 100 centimeter, right? Yes. At 25 centimeter. Tension at 25 centimeter. Okay. So, just you apply very first one. What you do? I said you that when the mass of the block is, mass of the string is given, you consider it's like a block. Okay. Yes. For the first one, very first condition, F is equals to M into A. F means what? 4 is equals to M is 2 into A. Then A is equals to what? 4 by 2. This is 2 meter per second square. For the first one, no issue on this. F is equals to M into A. Just you can find about its acceleration. Now, for the second one is about, very second. Here, yes, where you want to find it? You divide like a 2-block system. You divide like a 2-block system. This is 4 Newton. Tension is what? T. Same again is what? T at this position. At what distance is asking? 25 centimeter. Okay. So 25 centimeter. Total is what you say? 100 centimeter. So this is what? 75 centimeter. It's a 75 centimeter. So this total mass is what? Let it be, it's a M1. This is what? M2. What is the total mass? 2 kg. How should I find M1? I said you. So from what? This method is what? Coefficient. That's what lambda condition we have taken as. What is the lambda? Linear mass density. Lambda is equals to mass per length. Now I am applying for this. Total mass, okay, capital M by total length. So the mass of this, whichever the part is required, M1 by its length, so small l, otherwise x. So what is the total mass? 2 kg. This I am writing about 2 kg by total length 1 meter. So the mass required for this M1 by length is what? 25 centimeter. I have mentioned this is what in centimeter. So this is what? It's a 1 meter. 1 meter means what? How many centimeters? 100 centimeters. Okay. So this is what? 25 ones are 25 fours are 2 ones are 2 twos are. Is it okay? So here this M1 is equals to M1 is equals to what we written? M1 is equals to 1 by 2. M1 is equals to 1 by 2. 1 by 2 means what? 0.5 kg. This is what? 0.5 kg. So same thing you can find for the second one also. What's there for this? Total mass M. Total mass is what? 2. by total length is what? 100 centimeter is equals to the mass required for whose mass 75 centimeter m2 by what? It's a, so m2 by, so this length is what? 75 centimeter. Okay, 25 3s are 25, 4s are 2 1s are 2, 2s are. So it will become as what? 3 by 2. This is what? m2 is equals to what you say? 3 by 2 kg. Now you can apply. So this acceleration is in forward direction. This one also is what? In forward direction. Same both of this. Write the equation of this. How should I write the equation? Net force. F net is equals to what? Yes. This, how many forces are acting on this? Only one. What is this? T. What is the F net? MA. MA means what? M2A is equals to what? T. What is the M2? M2 you got it from this here, 3 by 2. Okay, 3 by 2. What the acceleration we got? The acceleration, so this is what? It's a 2. It's a 2 is equals to T. 2 to cancel. T is equals to 3 Newton. It's a 3 Newton. Okay, so this is first one. Its mass, whichever is mass is given, this mass is what? It's a 3 by 2 kg. So it's what? M into A means what? 3 by 2 into 2. 2 to cancel. What is this? It's a 3 Newton tension. And what the tension? So this, that's it. If you want to find, if you want to use this one also, we can use it. F net is equals to what? 4 minus, if I want to write the equation. This is my answer. It's over. I got the acceleration, and next one I got it. It's a tension. So if you want to write this equation also, sir, no issue on this. What do you get it as? F net is equals to, so 4 minus T. F net means what? MA. M1A is equals to 4 minus T. You can substitute, you will get what? Same. It's a 3 Newton. Massive string, massive rope is considered. The rope is like a single block. Okay, the block means what? Like you divide, and individual masses you consider m1 and m2. So how do you calculate the m1 and m2? By taking the situation is what? Linear mass density. So how much mass is distributed, then write the equations, apply in the condition. So you will get about, so this type of questions will be asking what is acceleration, and next one is about what is tension. Okay, so this is the same case. For example, it is there on the horizontal surface. If this is the same rope, if I suspend vertically, if it is vertically accelerating upwards, okay, then what will be the tension at the point at the same length? Do you think so? It's a different or same? Let us see this. Now here the rope is taken. This is what? Rope. Okay, same the situation. Its a force is applied is F. Its length is what? L. This is the length L. Its mass is capital letter M. Like, is moving upward. So what forces will be acting on this? Gravity. It's what? Gravitational force is acting in the direction of the motion. Means in the vertical direction. So moving upward means what? Acceleration due to gravity is acting downwards. Sir, where you want to find? For example, I want to find at the distance x. Yes, this is the x. So remaining is what? L minus x. It's a L minus x. Now draw its free body diagram. How should I go for this? First one, divide into the one block like this. Applied force is capital letter F. So at this point is what? Tension T, and length is what? It's a x. Okay, so this is what? M1. First one over. For the second part of this one, I am taking as this is like, okay, so it's a second part. Like a second part means what? Like a second block, right? So this is like, it's a M2. Next, tension again upward. Its weight is what? M2G. and length is what? L minus x. Okay, like. And what other force is acting on this M1G? Its weight. So this is what? M2G on the lower part. Tension is what? Upward. Here on this one is what? Force, applied force is capital F. Okay, and acceleration is what? In a upward direction. In the same acceleration is considered. F net is equals to capital F minus M1G minus T. F net is equals to T minus M2G. F net is equals to T minus M2G. So from this case I can write this is what the two parts I divided as like a two parts. You know, already I said you that how do you find mass M1 and next one is the mass M2. Sir, capital M by L is equals to M1 by X. Which is M1? This. M1 is equals to what you write? M1 is equals to M by L into X. Capital M by L is equals to M2 by what? L minus X. M2 is equals to what you say? It's a M by L into what? L minus X. It's a L minus X. Okay, in the same M1 and M2 I got it. I need to write the equation. How should I write the equation? Net force. F net is equals to applied. See, once again check it about this. This total mass is given. Individual masses are M1 and M2 are there. I divided like a two systems, like a two massive blocks, and its a tension is what? So due to this T and this one also T, its weight is what? M1G. This is what? M2G. So F net is equals to what? It's a capital F minus M1G minus T. F net means what? MA. M1A is equals to F minus M1G minus T is my first relation for the above one. For this, if you see, this is what applied force is capital F. It's what? Weight is what? M1G and tension is downwards. Now you can take about net force. F net is equals to what you say? This is only T. Next one minus M2G. F net means what? MA. MA is what? M2A is equals to T minus M2G is second case. Yeah. So weight and like this and applied forces here from these two conditions. If you solve them, you will get acceleration, and next one is about tensions.